Welcome to this second chapter. We are learning everything you need to design custom screens with the Adquio ecosystem. You might recall from previous chapters that we had stopped at exporting variables in Adquio, right? We have this list of exported variables, and now we'll notice that these variables have an address here: 1, 2, 3, 4, 5, 6, etc. Alright, so we will need these addresses now to use them on our screen. Here we have a device connected to my screen. Simply, we will double-click on it, enter the password. Let's go to the desktop, and we'll see that on all Adquio screens, regardless of their size, from 4 to 32 inches, we will always have these 4 applications installed and on the desktop. First, there's the Casambi application, which is the default application that launches on all screens unless we change it. Next, there's the AnyDesk application, which we are using for this connection. Additionally, there are 2 different Virtuinos, Virtuino 6 and Virtuino 6 Viewer. There is a very important difference between these two, and they are used for entirely different purposes. Virtuino 6 is used for designing scenarios for our clients, while Virtuino 6 Viewer is used solely for utilizing those scenarios. Once we finish our project in Virtuino 6, we export it and load it into Virtuino 6 Viewer. This way, the end user can use what we've designed but will never be able to switch to edit mode. Therefore, for operational purposes, Virtuino 6 Viewer is the correct option. Let's then enter Virtuino 6, and to connect to our Adquio, we simply need to do the following. We will go to these 3 dots, to Server Settings, and add a new one. It will be of type Modbus TCP, and we will call it Adquio, in our case, Adquio Lite. And I know that at this moment, this screen is connected to one of the LAN ports of my Adquio Lite. Therefore, I can use 172.2020.1. This would be enough for now. To check if we have done it correctly and if this connection will work, we have a button down here that allows us to test this connection. It has given us a green message, which means that this connection has indeed worked perfectly. If the message is in red, it means it could not connect. And if it is in blue, it means it has been trying but hasn't succeeded. Alright, with this, we would already have our screen connected to our Adquio controller. We need one more thing, a module, and we need to add a new one with this plus, since there isn't any. We will also call it Adquio, and we need to assign it a number. It's important that we remember this number. We will give it a 1, which is the same number we configured here on the server when we activated the export via Modbus TCP. Here we set the slave number, this 1, so we must put the same number here. Similarly, we have a button here to test it. Since everything has gone well, it also shows in green. We will confirm the changes. Now, we have our connection with Adquio completely configured, and we simply exit by saving. We will see that it already appears in this list, and we must enable it. By default, it is disabled, so we enable it, and we see it turns green. Great, we are done. Now, we'll see in a very simple way how to connect objects to these variables. We saw that we have here, for example, the variable 1, which was the level of a device in the Casambi network. We know that the levels in the Casambi network range from 0 to 255. Alright, so we return to our device, and the ideal for managing a level is a potentiometer or a slider. We will select the slider option, and now we will see how to configure it. The first thing we will tell it is that we must connect to our Adquio Lite, and the second thing we will tell it is that it is channel 1 or address 1 because we could have more. And what type of variable? Let's see what type it was in Adquio. It was of type natural 16-bit. Natural means a 16-bit number with only a positive part, so it is unsigned. Okay? Because it has no signs, only positive numbers. So we have it correctly selected. Unsigned word. And what address? Well, very easy. For example, for our test, 1. As simple as that, 1. We already have our control perfectly connected to our Adquio. And that variable we are exporting isn't even a variable from our Adquio. It is a variable directly from the Lithernet device. Therefore, by moving this potentiometer, we will be modifying the value directly in the Casambi network, without any intermediary and without any delay. The possible values it can contain, the maximum and minimum, are indeed as already indicated, from 0 to 255, so we don't need to modify it. Let's modify, for example. First, let's see what size it sets, and here we have an important option. Send the value when the movement ends, and also the option to send the value during the movement. The ideal to not saturate the Casambi network is to send it when the user releases the potentiometer, not throughout the movement, because otherwise we would be sending messages massively to the Casambi network. Okay, therefore, the value as proposed by default is correct. With this, we would already have this potentiometer working, and it appears here. Simply, if we click on it and drag it, we place it centered. And now you see, we are in edit mode, because we can move the values on the screen. We can click on an element and change its properties. To go to execution and see this as the end user would, what we must do is click on this green check mark here. If we click it, we will see that we can now move our potentiometer. Okay, and most importantly, we can also see if we are checking the values of our variables. We will filter by levels with an asterisk in front. The device Dokun1 level you see has 255. Let's make it not occupy the whole screen and lower it. Do you see that it wasn't working? It wasn't working because I didn't have it connected. I had to tell it here, connect. Now we see that by moving this directly, the value is modified in our Adquio. This would be the first very simple example with a potentiometer. We can make many changes to the potentiometer. First, let's see how to go back to edit mode. To do this, we will go to these 3 dots up here and select Unlock Panel, and we are back in edit mode. So, very simple. To go test it as the user sees it, here, and to go back, Unlock Panel in the 3 dots up here. Alright, let's see some more details about potentiometers. You will see that we can change the button, we can change its color, or we can upload our own. We will leave the one it had, which I like, and we see that, for example, we can also make it vertical or horizontal, depending on the design we are doing. We might prefer one or the other. I like vertical more, so I leave it vertical. To do another test, we will use, for example, a switch, which would be the most typical. These switches, we will select one of the most used ones, for example, this one. We will connect it to the same variable so you can see it's always the same. We select Adquio and we select the address, 1. It's important to see that this switch has here what value it should send for ON. In our case, it would be set to maximum, for example, 255, and for off, 0. Nothing more, it will behave like a switch. We confirm it, it appears here. We execute, and we will see that it is on, and if we click it, since the potentiometer is hooked to the same variable, both change together. And if we look at it from behind, we see that indeed it is showing 255, 0, 255, 0. You see, it is immediate. Okay, this would be the first example where we are already using components from the screen designer in the Adquio screen, and we already have them connected to our variables inside the Adquio controller. As you can see, it has been very simple. We just go to the export, look at the address of each of our variables, and use it in the property. First, we exit to edit mode again, and we use it in the property of the decimal address of our variable exactly with the same number. Okay, we select the port of our Adquio. There are no more options, but it is important to select it, because if we don't set it, it will not work, and we select the same type of variable. It is significant to explain one thing to you at this point. The variables most typically used to send data from Adquio to both screens and SCADA are usually always the same and are usually two. A 16-bit integer variable without a sign. Why is this variable used? Because to send values like light intensity, which is a value between 0 and 255, a 1, a 0, to know if something is activated or deactivated, 16 bits without decimals and without a sign is more than enough. The other type of variable widely used is 32-bit floats. Why this type of variable? Because it is a value that natively supports decimals, so if we want to send a temperature with decimals, a humidity that may have decimals, or in general any value with decimals, it is the most typically used value. When selecting a 32-bit float in Adquio, here you should select a 32-bit float with two big endian registers. It's important not to confuse it with the 32-bit float above, because if we use the one above, it will not work. It will not bring the variable correctly. It is always the big endian. In this case, we won't touch it because we will leave the one we had. And with this, we have finished this small chapter on screens, in which we have seen how to bring variables from Adquio to the screens, how to generate the connection with the server, and how to connect small components to directly modify variables in Adquio. In this case, we have seen a slider or potentiometer and a switch. In the following chapters, we will continue improving all of this and giving it much more power so that you have the opportunity to design your interfaces to your liking. Well, we'll leave it here for today. See you in the next chapter.